something we can work with, okay? So where I left you guys were looking at like El Nino cycles and albedo. That was kind of the topics of the day, the other day. Yesterday with the substitute, the idea was for you guys to move past the, the ocean portion onto the greenhouse gases and maybe even start looking at those anthropogenic fingerprints, that section. Again, something didn't even notice. I'm not sure how far you guys got, but I'm going to do my best to kind of try to touch on the things that I anticipate you guys might have had some trouble with. Now, the first and probably most important thing is going to be greenhouse effect, all right? So this is the first thing we'll talk about. There might be some of those issues with the El Nino cycles that maybe didn't get resolved on Tuesday. We'll just have to try to get those tomorrow, Friday. We'll see. I mean, we'll just kind of see how that goes. All right. But so we have the greenhouse effect. Okay. Now, within the greenhouse effect, what we have to also be able to do is differentiate. We're going to do a little bit of differentiation here between the natural, what we call the natural greenhouse effect, and what might be called the enhanced greenhouse effect. Okay. So let's differentiate here. We got the natural, and we've got enhanced. Okay, so what we'll do is I'll just kind of talk about basic fundamentals of the greenhouse effect, and that'll tie in some of the stuff we talked about back in chapter 5 with regard to solar energy coming in, hitting the surface, and how that warms the atmosphere and so on. Talk about kind of the importance of the greenhouse effect, the natural greenhouse effect, and then where we're concerned is with that enhanced greenhouse effect. So this is kind of the key for this little mini video lecture here. Is we want to make sure we understand the greenhouse effect and what it is, all right, how it works. We have to be able to describe that, by the way, and then we want to be able to differentiate between kind of that natural greenhouse effect versus what we're calling the enhanced greenhouse effect. And this is sort of that anthropogenic portion we've been kind of alluding to throughout this whole exercise since essentially Monday. Okay. So here is kind of a very, very overly simplified version of the greenhouse effect. Okay, I'm just going to change boards so I have some more space. All right, so as you guys should know at this point, everything kind of starts with the sun, right? So we got the sun, 93 million miles away. It's a happy sun, right? Doing its thing, right? It really doesn't concern itself much with what happens on the Earth, right? The Earth is sensitive to what happens on the sun, and not so much vice versa, okay? So there's the sun, and then we've got, I'll do a blue for the Earth here. Right? So there's the sun, there's the Earth, not to scale, obviously. And I'll kind of draw like a greenish line around the Earth just to represent what's going on in the atmosphere. I'll even make that kind of dash line. All right? So we've got the sun, Earth system, the dashed green line, which you guys maybe not be able to see very well with my poor video quality here. Anyways, so that's representing the atmosphere. Okay, that little blanket around the Earth of gases, mostly nitrogen and so on. Okay, so here's how we want to look at this. The sun sends energy to the Earth, right? And as we talked about back in chapter 5, much of that energy passes right through the atmosphere and hits the surface of the Earth. So we're not really heating up that air yet, right? It's going through and hitting the surface. So things like water, trees, dirt, what have you, right? The stuff that's on the surface, that tends to get heated up first. So it gets that direct energy from the sun, right? It warms the surface, right? So that's, okay, so we're going to say solar rays warm surface. That's kind of step 1 there, okay? Solar rays warm our surface first. Now, when the surface warms up, now we're going to start radiating some of that heat back into the atmosphere. All right. So I'm going to call this, just for lack of a better term, we're going to call this short wave. Okay, short wave radiation. All right. Now, as the surface of the Earth warms up, it's going to radiate that energy back as infrared, which is what we're going to call long wave radiation. Okay, so short wave radiation comes in. We've got kind of long wave. Okay, I'm going to write IR there for infrared, and that is a horrible looking R. I'll fix that right now. Right? So, again, short wave radiation, so the sun sends actually all kinds of different wavelengths at us, right? But that short wave radiation tends to strike the surface of the Earth. That heats the surface up. As the surface heats up, it radiates some of that energy out into the atmosphere at that point. That radiation has a longer wavelength. And most of it's in that infrared spectrum, part of that whole spectrum of wavelengths, okay? Now, that's kind of the key here is, first of all, we're heating the surface up first, and the surface warms the atmosphere, all right? Now, the atmosphere, as you guys know, is composed mostly of nitrogen, but it's also got some trace gases that are actually really, really, really important to us, right? So, things like carbon dioxide, for example, which we've heard about. We've got things like methane, okay, and things like water vapor, right, in our atmosphere. Now, those are some examples. Those aren't all of them, by the way, but they are some examples of what we call greenhouse gases, okay? Now, the name greenhouse is kind of referring to what happens inside a greenhouse, although the fundamentals are a little bit different. But what greenhouse gases do, and this is a phrase I want you guys to kind of get jogging, remember, they don't trap heat, okay? They often say that when they're talking about greenhouse effect, they're not trapping heat, okay? They are gases that, because of their properties, they're able to absorb infrared radiation, okay? So I'm going to write GHGs. Right? So GHG stands for greenhouse gases. I'm going to write that a lot. I just want that out there, okay? What they do is they don't trap, they absorb IR, okay? So IR being infrared, those long wave radiation, which is what we're calling infrared, okay? They absorb that infrared radiation, right? Now, when they absorb it, they re-radiate it. Back to the surface. Okay? Now, so basically what that means is, so the sun warms the surface warms the atmosphere. Some of the gases in the atmosphere absorb some of that outgoing infrared radiation and put it back to the surface again. Okay? And what that does is that bumps our kind of normal temperatures up a little bit. So because of greenhouse gases, okay, instead of saying we're going to trap heat, essentially we're going to create a longer residence time in troposphere for IR. Right? So basically it's making that energy that comes in and would normally radiate out to space, it's making it stay in the troposphere a little longer. And so we're able to retain energy for a little bit longer, and so that makes temperatures a little higher than they would be without those greenhouse gases, okay? And particularly at night, okay? And that's a really kind of key component, all right? So this is our natural greenhouse effect, by the way. This is a natural process. Okay, and in fact, you and I should all be very appreciative of this process because if you guys will recall, so with greenhouse effect, right, our average global temperature is about 59 degrees Fahrenheit, although slowly getting higher over time. Okay, without the greenhouse effect, our average global temperature would be about 0 degrees Fahrenheit. So really chilly, there'd be a lot fewer people and a much shorter growing season. We'd have all kinds of trouble, right? So that natural greenhouse effect, this natural process, okay, is where gases like carbon dioxide, methane, and water vapor, along with nitrogen oxides and some ozone and so on, right? They absorb and re-radiate some of that outgoing infrared radiation back to the surface, all right? And in doing so, that makes the energy stay in the troposphere a little bit longer than it normally would, okay? And if the energy stays in there a little longer, we get a little bit warmer. And the result of that natural greenhouse effect is a nice, comfortable, livable 59 degree Fahrenheit average global temperature, all right? Keep in mind, without greenhouse gases, so if we got rid of that greenhouse effect altogether, we'd probably be sitting at an average temperature of about 0 degrees Fahrenheit. So natural greenhouse effect, good thing, all right? So what we need to do now is differentiate. So we talked about this natural greenhouse effect, good process, good for living things, right? What we're concerned about is this enhanced effect, okay? So what happens if we kind of turn the thermostat up, right, by adding some extra greenhouse gases that wouldn't be there naturally, all right? So essentially, if we put more carbon dioxide in the air and more methane in the air, are we going to trap, not trap, are we going to absorb more energy and have it even longer residence time than with that natural effect, right? So that's the concern. So I'm going to switch boards out again. We'll kind of go through this enhanced greenhouse effect in a little more detail, okay? I apologize, my camera is recording really dark. You can barely see my face. Maybe that's a good thing, I don't know. But anyways, hopefully you guys can see the board okay. It's not really my face, it's important anyways. Enhanced. So we talked about the natural effect, now we're going to go into this enhanced, right? So if we have excessive amounts of things like carbon dioxide, which is our primary gas of concern, because that's the one that's really, really increased recently. But also of concern is methane. And methane is becoming increasingly concerning for lots of reasons. Anyways, it's starting to spike as well, and it's a much more potent greenhouse gas than carbon dioxide, although in much, much smaller quantities. So that's why we're still saying that CO2 is our big concern right now. Okay, so if we have excessive amounts of carbon dioxide and methane, right, and there are anthropogenic sources for that, okay, what we're going to see is increased absorption. Of infrared radiation, right? So increased absorption of IR and increased residence time. Okay? So we're going to increase the amount of infrared that gets absorbed and re-radiated, so absorbed and re-radiated, right? That means it's going to spend a little more time in the troposphere, okay? And if we're spending more time in the troposphere, thermodynamics says we increase the energy of a system. Really the only result that we can always predict is warmer temperatures, okay? So enhanced greenhouse effect, it is the greenhouse effect. It's just we've kind of put it on steroids, right? We've turned that thermostat up a little bit by increasing two really important greenhouse gases, carbon dioxide and methane, through human activity, primarily the burning of fossil fuels, but also some land use, chopping down trees. Methane amounts of actually, a lot of that has to do with agriculture, and actually melting permafrost, which is another feedback that a scary one actually. Okay, we get excessive amounts of those from human activity, right? That's going to increase the absorption of infrared radiation, which is going to increase the residence time of that infrared radiation, which means thermodynamics comes into play here. More energy in the system, more energy turns into heat, and we warm things up. Okay, and that's our greenhouse effect and enhanced greenhouse effect in a nutshell. All right.